There's a sentence buried inside an NBC News investigation published on April 17th, 2026 that almost nobody outside of professional meteorology is talking about. And it is the sentence that reframes everything you thought you understood about what happened this week, what is building for next week, and why the turn this storm system just took is far more dangerous than the radar loop alone can show you. That sentence is this. For much of Monday, the National Weather Service's Storm Prediction Center did not anticipate a tornado threat for the Kansas City area. Then 5 tornadoes hit that evening. 5 tornadoes in one of the most populated metro areas in the American heartland, on a night when the agency responsible for warning those communities had not placed them in a risk area at all. And the reason, the actual documented, confirmed, meteorologist verified reason, was not human error. It was not bad science. It was something far more structural, far more alarming, and far more consequential for what is about to happen in the next 10 days than anything the radar is currently showing. It was data, specifically the absence of it. Because the morning forecast models that should have seen those Kansas City tornadoes coming were run without atmospheric data from a zone stretching from the Four Corners region through the northern plains, the exact area where every one of the atmospheric ingredients for that outbreak was already developing, already building, already organizing itself into the supercells that 5 hours later would be dropping confirmed tornadoes onto a metro area that had received no watch, no elevated risk designation, and no reason to believe Monday evening would be anything other than a volatile but uneventful April night. The storm this week just took a big turn. It is not the turn that most people are watching on radar. It is the turn that explains why the next round, the one the models are unanimously flagging for Wednesday through Friday of next week, arrives at a moment when the early warning system that has protected American communities from killer tornadoes for decades is operating on incomplete information, compromised infrastructure, and a staffing level that a 29-year National Weather Service veteran described in print this week with a single word: unprecedented. Start with what was already true before the big turn revealed itself. Because the context is the story, and the story is not simply a weather event. It is the story of a season. By the time the April 17th outbreak concluded, the United States had recorded 356 confirmed tornadoes for 2026, a number that had jumped by more than 40 in a single week, driven by a sequence of severe weather events arriving in the American heartland with the mechanical, relentless rhythm of a storm conveyor belt that no seasonal forecast had fully anticipated. The 2026 severe weather season had been projected by AccuWeather's long-range forecasters as front-loaded, heavier toward March and early April, quieter later, with a total tornado count of 1,050 to 1,250, near the historical average of 1,225. Those projections were built on analog years. They were built on the assumption that the atmosphere, having delivered its early season energy, would begin to exhaust itself. They were built on the assumption that what happened in March, an EF2 tornado that killed a mother and daughter along U.S. Highway 60 near Fairview, Oklahoma, 4 deaths including a 12-year-old boy in southern Michigan neighborhoods, 204 confirmed tornadoes in a single month, the third most active March in the modern observational record, would represent the season's peak, not its prologue. The atmosphere has not read those projections. It has not acknowledged them. It has spent the first 17 days of April delivering round after round of severe weather onto a landscape that was already saturated, already swollen, already operating at the outer edge of its capacity to absorb another drop of water or another supercell, and then on Monday, April 14th, it delivered something that should not have been possible given what the forecasting models were showing that morning. It delivered 5 tornadoes to Kansas City without warning. To understand why that matters, you have to understand what a weather balloon actually does, not in the abstract, but in the precise operational sense of what happens when morning forecast models run and those balloons have not yet been launched. Weather balloons are the atmosphere's autobiography. Twice a day, every day, for decades, National Weather Service offices across the country release instrumented balloons that rise through the troposphere and measure temperature, humidity, pressure, and wind at every altitude they pass through. Raw, real, world, 3-dimensional data that gets fed into the high-resolution forecast models that meteorologists use to determine where severe weather will form, how intense it will be, and where it will track. The morning launch, historically at 7 a.m. local time, is not a formality. It is the data that seeds the high-resolution runs that run just after that hour. Miss the 7A Hemisphere launch, and those models run on data that is hours old, sometimes from the previous evening, representing an atmosphere that was fundamentally different from the one that exists at 7 a.m., on a day when conditions are actively destabilizing across an entire region. And in the spring of 2026, across multiple National Weather Service offices throughout the Great Plains, the 7 a.m. launches stopped. Not because of equipment failure, not because of weather, because there was nobody available at those hours to launch them. Staffing cuts that accelerated after the Trump administration's January 2026 federal hiring freeze, cuts that had already cost the National Weather Service more than 600 employees, according to NPR, had left offices like the one in Omaha, Nebraska, operating at roughly half their designed staffing capacity. Brian Smith, who spent 29 years as the warning coordination meteorologist at that Omaha office before retiring in 2023, reviewed what had happened and said in print that he had never seen anything like it. "This is unprecedented," he said. Not difficult, not challenging, unprecedented. The balloons shifted to noon launches at multiple Great Plains offices, timed for when more staff were available, and on the morning of Monday, April 14th, 2026, the high-resolution forecast models that the Storm Prediction Center uses to determine tornado risk for the Kansas City area ran without upper air data from the Four Corners region, from the Northern Plains, and from portions of the Central Plains. Chris Vygotsky, a meteorologist and research manager at the Wisconsin Environmental Mesonet, looked at the data gap and said publicly, "We are missing data at the normal times." The models showed no storm development southwest of Kansas City. Then, at 8:31 p.m., the National Weather Service confirmed a tornado on the ground in Miami County, Kansas. 5 confirmed tornadoes, in a metro that had not been warned. This is the big turn, not just the severity of what happened this week. The 3 particularly dangerous situation tornado warnings issued in 81 minutes on April 17th, the EF3 tornado that tore through Union Center, Wisconsin on April 14th, the EF2 with 115-mile-per-hour winds that demolished 50 to 60 structures in Hillsdale, Kansas, and triggered a verbal disaster declaration from Kansas Governor Laura Kelly. The 3, 5-inch diameter hailstone measured near Lake Crystal, Minnesota, approaching the size of a grapefruit, one of 5 measurements at or above 3 inches from a single storm event. The 75-car pileup on I-70 outside Loveland, Colorado, caused by snow on the cold side of the same system. Vermont recording its first confirmed April tornado in 76 years of documented state history. All of that is real, all of it is documented, all of it belongs in the category of genuinely serious. But the bigger turn, the structural turn, the one that changes the risk calculus for everything that happens in the next 10 to 14 days, is the confirmation that the forecasting infrastructure underneath all of it, the system that is supposed to see these storms coming before the first rotation appears on radar, is operating with gaps that independent meteorologists are publicly describing as dangerous, specifically because the heart of tornado season has not yet arrived. Vygotsky's words from the NBC investigation deserve to be repeated because they were not uttered casually. I'm concerned with any severe weather day, and the real heart of tornado season is late April and into May. Late April, which is right now, and into May, which is next. And the models are pointing at something for the middle of next week that every major global ensemble system is flagging with a consistency that the Storm Prediction Center reserves for situations it considers genuinely, documentably real. Here is what the atmospheric setup actually looks like for Wednesday through Friday, April 22nd through 25th, 2026. The cold front that swept eastward this weekend, the same front that ended the historic early season heat wave that had pushed temperatures to 93 degrees in Washington, D.C., 94 in Richmond, Virginia, and near 86 in Central Park. The same front that brought a temperature swing of 40 degrees or more in less than 48 hours from the 90s to the 40s across Michigan, Ohio, and New England. The same front that brought killing frost to every tree that had bloomed early in response to what AccuWeather senior meteorologist Alex Sosnowski documented as temperatures running 2 to 8 degrees above historical averages across the east. That front will be the temporary pause. Sunday is quiet. Monday is quiet. The Canadian high builds in. The air is dry, continental, cold. Frost advisories linger across the northeast for the gardeners who planted too early. And then, by Tuesday night and into Wednesday, the atmosphere begins its reload. A large-scale trough, a deep, amplified dip in the jet stream centered across the western continental United States, begins advancing eastward, and ahead of it, the Gulf of Mexico begins pumping moisture northward into the plains and Midwest with an aggressiveness that the ECMWF, the GEFs, and the EPS ensemble systems have been consistently flagging for days. The signal that elevates this from possible to probable is a single number, mid-60s Fahrenheit dew points across the plains into the Midwest by midweek. That number, mid-60s, is not meteorological shorthand for a humid afternoon. Mid-60-degree dew points in the third week of April represent atmospheric moisture content that belongs in June or July. They are the same moisture pool that fueled Cape values approaching 3,500 joules per kilogram during the April 17th outbreak. They are the same moisture signature that sat beneath the supercells that produced those 3 particularly dangerous situation tornado warnings in 81 minutes, Put those dew points in front of a well-organized mid-level trough with strong deep-layer wind shear, and you do not get scattered afternoon thunderstorms. You get the exact thermodynamic environment that the Storm Prediction Center's own language describes as capable of producing a much more substantial severe weather event across the central and southern plains. The GFS and the EC-AIFs are showing a consolidated trough, not multiple smaller disturbances, but a single coherent mid-level feature, which is the atmospheric configuration that produces not isolated supercells, but organized multi-storm outbreaks capable of long-track tornadoes, widespread wind damage measured in the tens of thousands of square miles, and rainfall totals that, on the landscape currently occupying that region, have nowhere to go except directly into rivers that are already at or above their all-time flood records. Because the Great Lakes and Upper Midwest are not a landscape at rest. They are not a landscape that absorbed the past 6 weeks of relentless atmospheric violence and emerged ready to accept more. The Wolf River in Wisconsin ran nearly a full foot above its own all-time recorded flood stage this week. Not above flood stage. Above its record, a threshold that, until April 2026, had never been reached in the modern observational history of that river, exceeded by a full foot. The village of Shiocton, Wisconsin, declared the majority of its streets impassable. Evacuations were ordered in Waupaca County. The Cheboygan Lock and Dam Complex in northern Michigan spent the morning of April 17th measured at 16 inches below the top of the dam, 5 inches, the width of a human hand, separating containment from catastrophe, while 75 Consumers Energy workers staged a round-the-clock emergency effort to restart a hydroelectric turbine that had sat dormant since a fire in 2023, amid a private ownership dispute, despite federal inspectors documenting cracked concrete and malfunctioning floodgates as far back as 2019. More than 20 separate river monitoring locations across Michigan and Wisconsin hit major or record flood levels before the April 17th storms had even fully formed. The Climate Prediction Center's probabilistic hazards outlook is currently flagging possible flooding for parts of the Great Lakes region and the upper and middle Mississippi Valley from persistent near to above normal precipitation, accelerating spring snowmelt. A snowpack in the Great Lakes watershed that entered this spring above normal, flowing into soils that are already saturated beyond their capacity to accept more water. Every additional inch of rain that falls into this region in the next 2 weeks does not soak into the ground. It routes directly, immediately, and completely into a river system that is already overflowing. Now add the ENSO transition, because the atmospheric pattern that is generating this relentless conveyor belt of severe weather is not operating in a vacuum. The tropical Pacific, which governs the large-scale climate patterns that determine where jet stream energy concentrates and where Gulf moisture transport is strongest, is currently in the transition zone between La Nina and ENSO neutral conditions, an 80% probability of neutral through June, with El Nino emergence at a 61% probability by July. Meteorologists know this transition. They know its history. The shift from La Nina to neutral or El Nino is not a smooth handoff. It is a volatile interval, a period when the atmospheric steering patterns that govern storm tracks become temporarily unstable, when the jet stream locks into configurations that neither La Nina nor El Nino fully controls, when moisture transport from the Gulf runs ahead of the season's typical schedule, and the storm tracks shift in ways that seasonal forecasts built on analog years cannot fully anticipate. It is worth noting that 2026's analog years, 2023, 2009, 2001, 1985, 1976, 1951, were all selected specifically because they featured the same ENSO transitioning negative PDO pattern that is present right now. And every one of those years featured the front-loaded severe weather season that forecasters predicted for 2026. What none of those analogs fully accounted for was a landscape as deeply saturated as the current Great Lakes and Upper Midwest, a region that has run at one of its wettest starts to spring on record, with rivers that never return to their normal channels between individual storm rounds. Step back from the individual events and look at what April 2026 has measured so far, because the measurements matter. The total tornado count for 2026 stands at 356 confirmed tornadoes by April 17th, on pace to challenge a historical average that the season's own forecasters believed would be approached gradually and distributed evenly across the spring. The heat wave that ended this weekend set nearly 600 temperature records across the country. A dam came within 5 inches of failure. 20 river monitoring locations hit major or record flood levels in a single week. 3 particularly dangerous situation warnings, the second highest tier of tornado alert, reserved for storms that are likely to produce destructive, long-lived tornadoes, were issued in 81 minutes on a single afternoon. Vermont saw its first April tornado in 3/4 of a century. And the two EF5 tornadoes that have now occurred in the United States within 10 months of each other, the Enderlin, North Dakota EF5 in June 2025, and the Wells County, Indiana EF5 in early 2026, represent the end of a 12-year gap during which not a single tornado in American history was rated at the violent EF5 threshold. Between 2013 and 2025, not one. Then 2 in 10 months. EF5 tornadoes represent approximately 1% of all confirmed tornadoes in the United States. They account for a disproportionate share of tornado fatalities. And they have now appeared twice in the span of a single severe weather season that forecasters projected would run near the historical average. This is the turn the storm just took. Not a single dramatic pivot visible on a radar screen. A structural reorientation of the atmospheric pattern of the forecasting infrastructure meant to anticipate it, of the landscape it is about to reload into, and of the seasonal context that was supposed to provide the guardrails. The cold front passage this weekend was not the end of the story. The quiet Monday and Tuesday are not a resolution. They are the breath before the next sentence. The mid-60s, dew points that every major global model is placing over the central and southern plains by Wednesday, are being computed by models that, the last time a major plains outbreak formed, were running without upper air data from the exact region where the atmospheric forcing for that outbreak was building. Chris Vygotsky said it plainly, and it needs to be said again. The real heart of tornado season is late April and into May. Not mid-April, not the storms that already happened. The heart is ahead, and the atmosphere is not exhausted. It is not retreating. It is reloading into a landscape where the rivers are already at their records, into a forecast system that is operating with acknowledged gaps in its atmospheric data, into a season that was supposed to wind down but has shown no intention of doing so. The big turn this storm took was not a turn toward quiet. It was a turn toward something the models are describing with the kind of multi-system agreement that meteorologists call a signal. Not noise, a signal. And the landscape it is about to arrive in has already used up most of its margin for error.